So, as I said, ladies and gentlemen, so you pick up two handouts. One of them is crossword puzzle. So the crossword puzzle is, if you look at the clues on the back side, they're mainly terms and names and peoples on chapter 7. Last year we did a chapter 7 quiz, and I used some of those questions to put on this crossword puzzle. I don't think we're going to be doing a chapter 7 quiz, considering we're already having a unit test soon. So in this case, make sure you do this crossword puzzle. This is a way for you to see, do I know this stuff or not? Okay. And if you realize, certain things like, wait a minute, I didn't really make notes on that, make notes on it. Okay. Now, we're going to talk about natural selection today, and we're also going to be talking about how do you frame your outline your paper. Okay, so let's look at this first. Natural selection. Natural selection. This slide, in some ways, we are talking about natural selection, but based on the two videos you have already watched, or you should have watched, the one about Darwin's journey as well as Wallace's journey. So you learn about natural selection. There are some case studies that we talk about, as well as genetic drift video that is in the video. So in this case, a lot of this would not be new. So I'm kind of on certain aspect, I'm going to move fairly quickly. But this gives us some kind of terminology in terms of what kind of selection there can be, and what are some causes of selections. Okay, so now again, natural selection needs to have two things need to happen. You need to have mutation and variation. Without those two, genetic mutation as well as genetic variation, natural selection cannot happen. Okay, i.e., if your entire population is uniformly the same. If your population is uniformly the same, then in this case, you would not have natural selection because everyone's identical. Okay, so mutation as well as genetic variation is essential for, I just put NS, not Nova Scotia, NS to happen, okay? Natural selection. So unfavorable mutations will be selected against, and mutations that is beneficial, that will help you live long enough to make lots of babies, will tend to survive and pass on. Okay, so this is essential for NS to happen. Now, sickle cell anemia or sickle cell disease, we talked about it at length in this course already. Now, one of these maps, I'm not entirely sure which one it is, it's about the spread of malaria, and the other one is about the spread of the sickle cell allele. Again, do keep in mind, individuals who is heterozygous for the sickle cell allele have a certain resistance to malaria. Okay, it's harder for them. It's actually, they have a certain level of resistance to malaria, and malaria can kill you pretty fast. Okay, malaria can kill you pretty fast. So in this case, it is for those individuals in that context, it's favorable mutation. Yes.
What's the word say after heterozygous?
Individual, INDIV, shorthand, INDIV, have a certain resistance to malaria. Okay. However, if that individual, you take that person out of the context, you put them out of the environment, put them in a place where there's not really any malaria going on, that becomes an unfavorable value or mutation. Okay, so whether it's favorable or unfavorable, really it depends on where you're talking about and the context. Okay. Yes.
Can't we do both favorable and unfavorable at the same time? Or is that
Can you give me an example?
like you have don't you have to have if you have one you have to have the other one. If you have protection against malaria, you also experience the adverse effects.
I think there is a certain, you don't get full, for example, in certain sickle cell disease, you don't get full-blown sickle cell anemia. If there's any medical condition that you are more susceptible to, I'm not sure, at least it's not really usually talked about in textbooks. You do run into chances of like your kids having sickle cell disease. However, it seems like sickle cell disease, even with a full-blown sickle cell disease, a lot of times individuals do live long enough to have kids. So in that sense, that's why in that context, it's still favorable. Okay. Yes. What? When they become what? Residual, did you say? What? You'll have to come up and ask me a little bit later on. I can't really make out what you're saying. Okay, so now we have, in terms of selections, you have three main patterns: directional, stabilizing, and disruptive. Okay, directional, stabilizing, and disruptive. So what do we mean by that? Now, this is, by the way, this is what you call, a lot of times people call the bell curve or the norm distributive curve. So typically in most populations, you have a lot of individuals. You have a lot of individuals that are kind of average in the middle. Okay, that is typically what happens. Most of the individuals will be near the average of whatever it is. In this example, we're talking about fur color for mice. So most of them will be on the medium, on the average color. And then the extremes, very dark or very light fur, would be less. Okay? So this is what we call the bell curve or norm distributive curve. Now, when we're talking about selection, there are different kinds. So as I said, directional selection means if you look here, you have less of the lighter color fur, for example, but now as most of the population move toward darker color fur, okay, the curve actually shift to either one of the directions, okay? So that would be a directional selection. Disruptive selection means all of a sudden the average population is actually going down. Something is selecting against these medium color fur mice. We don't know what. And now the two different extremes, the lighter color mice or the darker color mice, become more favorable because you have a lot more of those two now. So that will be a disruptive selection. Stabilizing selection means both of your extreme ends are actually going down, number of them going down, and you have more and more becoming in the middle, more and more becoming the average population or average traits. So let's look over here. I wrote three things for you to remember. So selection direction, directional selection, you're shifting the bell curve. You're shifting your bell curve. Disruptive, you're having less of the average. In math, you call this kind of curve a bimodal curve. Okay, a bimodal curve or bimodal distribution. And stabilizing means you have less of the extreme. The number of average, the population is much more closer within the average range. Okay. Yes.
What's the word after average?
This one? Bimodal. B-I-M-O-D-A-L. Bimodal. B-I-M-O-D-A-L. Did I misspell it?
No, but could you explain what that means?
Basically, it's the normal distributed curve is like you have most of the population would be around the average and you have less of the extreme. Bimodal is like you don't really have the middle ground. You have a lot of the both extreme ends. Okay. Think of a test. A lot of times, your test result, usually you should have a lot of people, hopefully you have a lot of people in the average mark, and then not so many people failed, not so many people got like 90s. If some reason you have a bimodal distribution, means a lot of people did really, really well, and a lot of people failed, and not a whole lot of average mark. Okay. Are we good? Not selection. We're talking about norm distributed curve. Yes, a lot of things do use norm distributed curve. Okay, questions. Okay, so directional selection. So let's look at some examples. So directional selections for example, hummingbirds. The length of the beak, because they feed on the nectar of the flowers, okay, they feed on the nectar of the flowers, it is usually the length of the beak will be selected for closer and closer to the depth of the flower that they need to have, okay? Another example is this one here. What's the name of the very famous mountain around Tibet? What? Himalayas, Mount Everest. Yeah, isn't that one of the names, like the name of the range, and one of them is just that particular mountain? So, anyways, not just Tibetan, but a lot of people around the Mount Everest area. A lot of times they actually have done biological testing on them, and what they found out is that they typically have a much higher red blood cell count genetically, which makes sense because they live in very high altitude. Oxygen is a lot thinner, or air is a lot thinner. So it's actually a beneficial trait for them to be able to carry more oxygen in their blood. Yes?
Does that mean they would be better at like sports and stuff because they can pump more blood?
In certain aspect, that will be a beneficial trait. Also, it's also no surprise in a lot of times, a lot of that population work as mountain guides. So people want to climb Mount Everest, they certainly need mountain guides and help. So they will become Sherpas. Questions? Yes.
If I live like up in a mountain for a long period of time, would that like change my biological?
Now it's interesting because I was talking about this with the first period class. You can actually train yourself to have the higher red blood cell counts. That's what a lot of times athletes do. That's what certain special forces do. However, in this situation, we're talking about like a genetic one, not the. What was that theory that was disproven?
Use and misuse.
What's the guy's name?
Of Chevalier Lamarck.
Lamarck. Okay,
Yeah.
that's where. Yeah. So it's not like, oh, if you go live in the mountains for a long time, then your kids who are born there, no, we're not talking about that. Okay. Questions? That's Lamarck.
Still like this theory.
Yes.
Could you explain the bird example again?
The bird example, because hummingbirds feed on the nectar of the flowers. So in this case, the selection would be more towards birds that have the beak length that is suitable for the flower that they feed on. There has actually been human experiment, not human, experiment on mice by humans. So what they did was they select mice they check for high runners for breathing, and after a number of generations, the distance for the mice that can run, as well as the speed that they can run, is also improved. So this will be a directional selection. Okay, so this will be in an example of an artificial selection process. Now, so that's what we have in terms of the directional selection. Now, stabilizing selection, what on earth do we mean? And there are 3 pictures of babies. The reason why is this. It tends to be, for human baby weights, tend to be a stabilizing selection. Now, before we even look here, how many of you know your birth weight? Did your parents ever tell you, like how big you were, how heavy you were when you were born?
How heavy? 60 pounds.
You're definitely not 60 pounds.
Scaling. I forget what the number was, but I need to know the scaling first.
60 pounds?
Yeah.
That's like, I don't know, 25 kg?
How big is a suitcase?
Yeah, that's a suitcase. That's like that's a checked luggage suitcase. That's a checked luggage suitcase. Okay. Why did you bring that up? Okay. No one know their birth weight. Okay. In the our first period class, there were like a few more people.
So 30 pounds would be 12.5.
Could you, why are we?
Why are we talking about these outrageous numbers?
He needs to know. And you know it's good.
We're talking about human babies.
What?
We're talking about human babies, not cattles, right? So, now I know my birth weight was 8 pounds 7 ounces. 8 pounds 7 ounces. Okay. I know a lot of my kids' birth weight was somewhere about here. But if you look at this data here, now mind you, this was data from 1950s, so things might be different nowadays. I don't know. But as you see, you don't get like very extreme weights. The reason why is this. If the baby is born too small or too light, the chances of them dying within the first year is quite high. Okay, basically after 5 pounds, that percentage goes up quite a bit. 5 pounds is about 10% in mortality rate. Okay, so it's not good for the babies to be born too small, but at the same time, it's not good for the baby to be born too big. Why is that?
Does it have something to do with like premature babies and
That would be baby born too small. But why is it bad for baby to be born too big?
Because the mother can drop it? I don't know.
I think we're talking about processes before the mother can even hold the baby. Yep. Yes.
Is it because, like, you know what? I can't say that. No.
You're passing a big baby out of you. That would be a very difficult labor. I know you have to. I know you can do C-section, but then the thing is that that's not typical, right? That's not typical. I shouldn't say typical. I mean, like, that's like surgical intervention. You're looking into that. We're not talking about just natural birth. So in this case, it's yeah, certainly not good to have baby that's way too big. So this is the reason why it's a stabilizing selection for human baby weights. Okay, good. Now, in terms of other selection process, you also have sexual selection process. After all, most species, we're not talking about random selection of mates. Okay, typically you have two factors. Two factors. They both happen usually at the same time. You have usually the female mate choices. Usually, it's the female who chooses which male they'll mate with. And number two, male versus male competition. What is this? So, what is the term for what kind of competition would this be? Male versus male competition. Yes. What? Not entirely. What was the? There's a I word in something competition.
Alpha competition?
No. Yes. Intra-species competition. Thank you. Intra-species competition. Okay. So let's look at these two peacocks. Which one is male? Which one is female?
The green, blue, red is the male.
Okay. This one is the male and this one is the female, which makes sense because in most animals, it is the female that chooses the mate. So in this case, most males would be usually very colorful, very flamboyant. It's to attract the mate. Okay, it's to attract the mate. Okay, usually the female of most species, the coloring would be more toned down. Okay, which makes sense because which one is in some ways would be dedicating more biological energy for producing the young. The female. What's the downside of being so colorful and flamboyant? Attracting predators. Okay, so you don't really want the female to get eaten. Okay. Now, male-male competition. So again, at the same time, you have male-male competition. This is also reason why a lot of times, and for most species, males will fight with other males for territories, and males tend to be fighting usually the larger one and louder one, okay, more flamboyant one. Seals. Okay, I'm guessing. So there is a video on sexual selection. Now, we're not going to watch it right now. It is a puzzle video. I just put it on, so you will watch that later. There are some cumulative selection process. You can read that. Okay. Genetic drift. Okay, genetic drift. We read. You guys watched that in one of the puzzle video. Okay. Keep in mind, this is one of those things. This is a random shifting. Okay. Usually, it's due to a random event. Natural disaster, for example, that will be a good example of that. Okay. So, a random event that shifts what they call the allele frequency. The allele frequency. So before, look at this diagram here, you have like 1/3 of the bugs will be green, but in this randomized event, 2 of those get squashed. So now 1 out of 7, which I can't easily convert in percentages, is green. So that allele frequency shift very quickly. This can also cause this can be linked to what you call a bottleneck event. Okay, linked to a bottleneck event. So in this case, let's just say this is the original population. And after the event, you only have so many left, for example. The surviving individual will mate, presumably. And next generation, if you look, the allele frequency is very different from the original population. Okay, it's not a reflective to how it was before. Question? Yes. Yes. Okay. Now, some examples of bottleneck events. Now, a lot of times this happened with endangered species. So 10,000 years ago, there was only about 7 individuals left. This was done by genetic analysis. Okay, we certainly weren't keeping records 10,000 years ago. So based on genetic analysis, it seems like 10,000 years ago, there was a very, very few number of cheetahs. And so because of that, cheetahs now, they're more susceptible to disease and have lower reproductive success. Again, this is a very common problem for endangered species. You don't have that much genetic variety, hence a lot of those recessive traits can pop up. Yes, very common problem for an endangered species. Yes.
For this, do you have to add spaces in between?
The what? I don't remember.
Because like for
Try your
each
best.
Beagle, I need one more letter.
I don't remember. I made this last year, so I'll have to double check.
I'll assume there's spaces.
Okay. So, another example of bottleneck events. Elephant seals. They were overhunted, and there were only about 20 individuals back in the late 1800s, estimated. So in this case, again, the current population of northern elephant seals genetically will be very similar to each other and wouldn't be representative of how they were before. Okay. Yes?
What did you write about?
I kind of scratched that. Yeah. Oh, it became purple on the screen. Okay, now, something very similar to genetic drift and bottleneck events. This is also what you call founder's effect. Although founder's effect, a lot of times those genetic drift is more like a randomized event. Founder's effect, it does not necessarily be a randomized event. Okay. So in this diagram here, for example, on the mainland, you have, it looks relatively even spread between the lighter color ladybugs and darker color ladybugs. But when 1 or 2 individuals of the darker ones go to the island and settle there, after a few generations, pretty much all of the ladybugs on the island would be dark color, because the founder of that population was of that particular one. So in this case, the allele frequency on the island is not representative of the mainland population. This happens, this founder's effect, we kind of, during the age of sail and colonialism, we actually noticed that a lot, especially if there's invasive species, like rabbits and cats that get brought onto like various places. Yes?
Is an example of stabilizing?
No, we wouldn't call it stabilizing selection, simply because this you're stabilizing selection, you're talking about the both extremes going away, right? You're having more and more in the middle. But this one here, you are talking about just because certain individuals from the main population go to an isolated area and settle and populate. So in this case, after X number of generations, how the population looks on the island comparing with the mainland would be significantly different. And that's how you explain that. Okay? Yes?
For example, if we were to take the example of these bugs,
Hmm?
if we were to take the example of the bugs, could you say that, like, overall, the bugs population is just like normal, but then like when you compare the new population of originally where the bugs came from and on the island, that it's a disrupting selection because in a smaller scale, the populations like alleles and whatever the bugs are different.
Don't necessarily think that would be what you. I don't think that's what disruptive selection meant. Let me look at the textbook and double check that for you. Yes. Okay, so now the effect on small populations. We're talking about more like genetic drift and founder's effect. So genetic drift, as I said, randomized events. This one, founder's effect, might not be randomized. But essentially, just like in the video, just like in the puzzle video, if you have a smaller population to start with, the effect of a genetic drift or founder's effect will be much bigger than if you had a larger population. Okay, if you have a larger population to start off with, natural disaster happened, it probably wouldn't impact the allele frequency that much. Or if you have a larger population of founders to settle at a new location, then in this case, the allele frequency won't be as different as compared to the mainland as if you only have a few individuals. Okay. A number of you are trying to read this French word over here. Yes. Okay. I kind of remember that. Any one of you guys know this story? Yes.
Pretty much when they sent people to colonize Canada, because they needed to increase the population and whatnot here for the colonies, they sent orphan women and girls to Canada to like get married to like people that came to colonize here so they could increase the population. And
yeah. So in the early stage of New France, it was mainly like a work camp. There was mostly guys there. There was very few women. And so in order to encourage the population growth, I think the government of France, the King of France, actually basically brought a whole lot of girls. They were given almost like the name and title of the daughters of the king. And they were given dowries and a lot of incentive to come over to New France and resettle. Apparently, like someone looked it up in the last period, like there were 800 of them. So that would be in some ways, like that would help reduce that founder's effect problem, right? You now have a much larger population, so it's not just relying on like 20, 30 people. Does it make sense? Yeah. Now, there is a math part to this, okay? There is a math part to this called Hardy-Weinberg principle or Hardy-Weinberg equilibrium. Yes?
I was just thinking about the cheetah, and I was wondering if there was only 7 individuals, how would they like expand their population to such a large number? Like, wouldn't there be like a crossing over of like
Insects? Oh.
They're cheetahs. They're cheetahs. I think if you look up their conservation status, I think they're still kind of at risk.
Aren't they supposed to have limitations then?
There are a lot of problems. They can still run really fast though, mind you. So anyways, coming back here, Hardy-Weinberg principle. So it's a math equation. By the way, the math is very easy. However, I know last year we didn't expect people to do the calculation with them. I'll double check with Ms. Lam to see whether that changed last semester. But this basically gives a benchmark. Gives you a benchmark. It's not a realistic number, okay? It's not a realistic number. It provides a certain benchmark so you can see like, hey, is there some kind of evolutionary forces at work? Okay? Were certain traits actively being selected against or being selected for? Okay? So it's a number so you can compare things with. Okay? Any questions?
What's that word?
Benchmark. Benchmark. Benchmark is like a number you can compare things with. Are we good? Now, homework as well as textbook questions. Okay. So these two things. I also have two puzzle videos. They are relatively short. I'll add the Class B link a little bit later. Now, I want to talk about how do you frame or make outline of your paper, because this is important. Framing and outlining your paper is important. Okay. A lot of you, the reason why I want to talk about this, a lot of you are at a stage where you should start thinking about doing this outline, because it will help you focus in terms of what should you be writing. It will help you organize your thoughts. And it is very important. And you can kind of like, rather than just randomly looking for like, okay, I need to get more research, it will help you direct, like maybe you have 80% of your research done, you just need a few more other things so you can focus on your final research. Now, here's a link here. I did add this yesterday afternoon. Is it here? Yeah. So this is by a library, college library from the States, I believe. So how do you do research, or you're talking about doing an outline? So there's a quick video. It's less than 2 minutes. We're gonna watch that. Okay. So now, because your paper, you guys have a very wide range of topics within your class. So I'm kind of giving a kind of a brief generic explanation and unpacking of these things. Okay, you don't need to rush to copy this. I will take a picture of this and add it to the unit planner. As you also remember, I'm recording this right now, so you can kind of see how I made all this up as it goes. Okay. So they said a thesis. Okay. Keep in mind, your paper is maximum 700 words. So 700 word is, according to Google, 1.4 page single space or 2.8 page double space. They didn't even talk about font sizes, so of course that will be important. So, introduction, I will suggest 3 or 4 lines. 3 or 4 lines, you don't need long. Don't worry about the quotes yet, but make sure you end with your thesis statement. Like this paper will talk about ... will be your finalized version of your research question. Okay. Earlier, while I was checking your research question, I say too broad, or need to focus on more, or you need to focus more on this field. You've done research now. You know way more about this topic now. Focus that now. Okay. Fine tune that. You will talk about, so this paper will talk about this, and then you start talking about the headings where you're going to go through. The headings that you're going to go through. So for example, here I have someone else's paper, not for this course. Now I'm not going to show it here. I'm just going to verbally talk about it. So for this person's paper, this is about the evolution of color vision. So they were saying this. This lit review will focus on the theorized reasons for evolution of color vision, genetic evolution of color vision, and the prospect of color vision, with overall emphasis on mammals, specifically primates. So if you listen to this basically, for me as a reader, with that thesis statement, I know now exactly what this paper is about, and you are essentially guiding me through your thinking process as well as what I'm expecting for you to go through. Okay, this is very important in almost all scientific writing. Okay, another paper here. This one, it's where is this thesis statement? Oh yeah. So this one talk about CRISPR. So this paper will use a thematic structure to discuss the mechanism of CRISPR system, its origin, its factor that influenced the CRISPR evolution, the way the CRISPR evolves, as well as future application. So again, this is a much bigger paper. So there are 5 kind of headings where they're going to go through. Any questions so far? Okay. So for us, which is only 700 words, I would suggest 3 sections, maybe 4. It depends on your topic. It depends on the paper. Okay. Now, for pretty much all of you, you should have, in your first section, talk about something about background or history. Okay, background and history. Okay, those will be typical first section. Now, it depends on your topic. Someone was talking to me about from first period, talking about the mass extinction event, because that's their topic. And they say, sir, then what's the difference between the background and history? It's like, well, I think based on what they're talking about, it sounds like the background is the history. Okay? Although for your other topics, it might be a little different. And definitely give definitions of terms. especially things that they don't teach in grade 9 and 10 science, and that was not in the grade 11 bio syllabus. Make sure you give definitions, and make sure you give in-text citation to that too. Okay, don't forget those things. Yes.
How exactly do we choose the definitions?
How do you?
Is it gonna be like, are you gonna like put a bracket around it and explain it, or just gonna?
No, you write it as a sentence. Yeah, and ideally paraphrase it. Okay, paraphrase it. Remember, if you use a lot of direct quotation, it seems to me like, did you actually understand this stuff yourself or not? Okay. So give definitions of terms. That is important. So typically, this will be the first section. I will suggest use separate headings, use subheadings for each of these. Okay. In scientific writing, it's very common to break down large chunk into various subheadings and with a label of each subheading. So it's very easy to read. Okay. Yes?
So if your background and history is the same, you just learn the same.
If it was the same, then yes. But again, it could be different. Like, for example, the mass extinction event that someone was asking. If their paper was talking about the various theory about those mass extinction events, then in this case, the background and history might be different. It might be like, oh yeah, the first theory was this, then the second theory was this, and then a third theory is this, right? So it really depends on your specific research paper. Okay? But right now, background or history, I'm kind of to be generic so everyone can adapt. Look at your own paper. But use a lot in text use a lot of subheadings to break things down and with label subheadings so it can be easily followed. You have probably 2 more headings, maybe sections, maybe 3. Okay, that would be talking about your main points of your paper. Since it is only 700 words, section 4 is a maybe. Also, when you start planning your outline and writing your paper, do keep track of your points, where they come from, because that will be important for you to do your in-text citation later. Earlier in first period, I did a practice run using the citation machine. So you can get not only the reference, but you can also get the in-text citation for you. I do say you need to make sure before you come to this step, there are a number of steps that say, please make sure all the information are filled in. Do that, okay? Make sure you do it. I don't want to see a lot of ND, no dates, or a lot of like no names or something like that. That's, to me, seems you really didn't do the research carefully for that, okay? Last but not least, a conclusion. In conclusion here, just like in the video, and the video gave a very good example on how that ends with. So you talk about your points again, you reword your thesis statements, and you come up with a concluding statement to kind of end with and wrap that up. Again, that will probably, a conclusion don't need to be long, okay? Do not need to be long. 5 lines or 5 sentences will suffice, because a lot of the bulk of your material information is in this section here, okay? Any questions so far? Yes.
When you say thesis reworded, this isn't like a persuasive essay or something where it's like, so what would the thesis reworded look like?
I think it's just reiterate your thesis statements. You don't need to copy that line by line again, but just reword slightly.
No, as in like, for example, like for mine, the thesis statement would be regarding like stem cells and rejection. Right? And so the thesis reworded, wouldn't it literally just be like, this paper was about this, or was it something different? That sounds weird.
Yeah. So in this case, based on what you just told me about stem cells research, as well as what's the rejection thing?
The immune rejection.
The immune rejection. So you can talk about things like, oh yeah, so blah 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 blah. After all this thing, you can probably say something again about in this paper we had explored this, and then you might talk a little bit about like, oh yeah, based on what we saw, it would be blah blah blah.
Okay.
It can be a way of how you end it. Again, it's different. Now, in my experience of writing papers, and I do not claim to be an expert, don't worry about the rest of your introduction. I usually write that at the very, very end. But this thesis statement, as well as the heading, make sure you do that first. And then you write the rest of your paper. And then afterwards, then you think about those 3 lines or 4 lines to go in front of your thesis statement on the introduction. Now, I said here, if possible, start with a famous quote, famous and relevant quote, okay? Not all your statements, not all your topic lends to that or lends to that. So don't force one. It actually looks a lot worse if you do. Again, you don't need, it's, yeah. Yes?
So wait, it shouldn't be like something we found in one of our like sources. It has to be something famous from someone.
Like a famous quote, famous sounding quote. Like, I know this is not biology, or like, for example, like, ask not what your government can do for you, but what you can do for your government. Spoken by JFK.
For example, like for my topic, if I want to like introduce it, because it's about antibiotic resistance, could I start it off with a quote related to like, oh, 20 estimated 20,000 or something people die each year due to
yeah, like a relevant stat that is from a authorized source, like I don't know, UN or WHO, that says like, oh yeah, yeah, something like that might work. Okay, but do keep in mind you do have a word count, maximum word count of 700. So I mean, keep something nice and concise. Yes.
Is there a hook?
Huh?
You're hooking the reader with a hook.
Yeah, it's like a hook. Good. Any questions? Yes.
For the title, do you want us to be creative with it, or does it matter?
Don't really need to be creative with it. In some ways, think of your thesis statement, but condense it.
Okay.
Yeah, condense your thesis statement even more. Okay, those would be like I worry about that at the very, very end. Okay, I worry about that at the very, very end. Any questions? Okay, so again, this is my brief note that I've gone over just now. I'm going to take a picture of this. And so, any questions before I stop recording? No, no, no? All right.